Hello everyone, my name is Ankita Mathur and the article which I am presenting today is Why GOMS, an article by Bonnie John in 1995. Bonnie John is a cognitive psychologist known for her work in the field of human computer interaction. Her major contributions were researches on computer programming, skill acquisition, and predictive human performance modeling. She was founding member of HCI Institute at Carnegie Mellon University. She is currently working as a UX designer at Bloomberg LP. John has been involved in studying how people interact with technology and how to improve user experiences. The concept of GOMS was introduced in a book about human computer interaction by Stuart Card, Tom Moran, and Alan Newell in 1983. GOMS stands for Goals, Operators, Methods, and Selection Rules. They suggested that when designing a computer system, it's helpful to analyze how people perform tasks using these components. For example, understanding the goals of a task, the operators involved, the method used, and the rules guiding selections. In this article, the author wrote that she was working on telecommunication systems at Bell Laboratories and wondered what GOMS is, how it works, and when to use it. Even years later, these questions persist in her mind, as well as in many others, including usability specialists, managers, and computer system designers. She spent 12 years studying and using GOMS. By now, the author transitioned herself from a systems engineer to a PhD holder in cognitive psychology and HCI, aiming to provide answers to these questions. The goal is to make GOMS more accessible and understandable for those in the field. The questions which arises in the author's mind and were discussed in this article are: what is GOMS? What can it do? In what situations does it apply? How do we use it? Who can use it? Can it be trusted? Is it worth the bother of using it? What is GOMS? It is a model used in HCI and cognitive psychology to analyze and predict the time it takes to perform a task. GOMS breaks down tasks into the following components to understand the cognitive processes involved in a task execution. GOMS stands for Goals, Operators, Methods, and Selection Rules. The first one is Goals. This represents the overarching objectives a user wants to achieve by using a software. Operators. These are the basic actions or mental processes that user perform to achieve goals. Operators are the actions that the software allows the user to take. With the original command line interfaces, an operator was a command and its parameters typed on a keyboard. Today, with graphic user interfaces, operators are just likely to be menu selection, button presses, or direct manipulation actions. In the future, operators will be gestures, spoken commands, or even eye movements. But in GOMS model, operators are like button presses and menu selection. Third one is methods. Methods are sequences of operators that are used to accomplish a particular sub-goal. They represent the step-by-step procedures followed by a user to achieve a goal. The classic example described by the author is deleting a paragraph in a text editor. Using a mouse, place the cursor at the beginning of the paragraph, hold the mouse button down, drag to the end of the paragraph, release highlighting the paragraph, then hit the delete key button. This complete sequence of action is known as one method. Selection rules. These rules determine the conditions under which a particular method or operator is chosen. Users follow in deciding what method to use in a particular circumstances. The author explains this by giving an example in a paragraph deletion Like if a paragraph is more than 5 characters long, then she will typically drag the highlight and hit the delete key button. If the deletion is 5 characters or less, then she will place the cursor at the end and delete back. Thus, personal selection rule depends on how long the paragraph is. Versions of GOMS. There are 4 versions of GOMS. The first one is the original GOMS. The second one is KLM, which is keystroke level model. The third one is NGO-MSL model. The fourth one is CPM GOMS, a parallel activity version which was developed by the author herself. This is a simple example of CMN GOMS on editing a manuscript. The CMN method, which is the original GOMS, can predict the operator sequence and the time taken in the execution on a quantitative level and can focus its attention on methods to accomplish goals on a qualitative level. This is the same example of the task which we saw in the earlier slide. In this, the task is moving text in a word processor in the context of editing a manuscript. According to GOMS analysis, it should take around 14.38 seconds to move text. The use of subgoals and selection rules can be seen easily here. This is another example of a simple code for copy and paste. Keystroke level model, which is also known as KLM. It uses only keystroke level operations. There are no goals, no methods or selections. Analyst lists the keystrokes and mouse movements a user must perform to accomplish a task and then uses a few simple heuristics to place mental operators. This is the example of KLM model. This is text editing task of searching a Microsoft Word document for all occurrences of a 4-letter word and replacing it with another 4-letter word. The use of notation of card ETAL 1983, where K represents pressing a key or a button, P represents pointing with the mouse to a target on the display, H represents moving hands to the home position on the keyboard or a mouse, M is a heuristic to incorporate mentally preparing for a task. The time intervals for an average typist is taken 55 words per minute. According to this model, it takes 10.2 seconds to accomplish the task. The next model is NGO-MSL, which was given by David Kiaras. It has a well-defined procedure for identifying all the components of GOMS. It uses ordinary computer language and rule of thumb about how many steps can be in a method, how goals are set and terminated, and what information is needed to be remembered by the user while doing the task. The NGO-MSL model predicts that it will take 5.28 seconds to highlight arbitrary text. CPM GOMS. It uses cognitive, perceptual, and motor operators in a critical path method schedule chart known as PERT chart to show how activities can be performed in parallel. All of these techniques are based on the same GOMS concept. This is the example of a schedule chart for implementing the goal red screen when an eye movement is required. The figure is taken from John and Kiaras, 1996. The sequence which produces the longest path through the chart is called the critical path, and it represents an estimate of the total time required to perform the task. In this case, if we assume a simple binary visual signal on the screen, the critical path is 50 plus 50 plus 30 plus 100 plus 50 comes to 280 milliseconds. This particular model assumes that visual perception, cognitive operations, and eye movements can occur in parallel. Now let's see what can GOMS do. It produces quantitative and qualitative prediction of user interaction with a proposed system. It also helps consumers to evaluate alternative systems before making a purchase. It assists designers in evaluating arrival design ideas during the specification stage of design. Benefits of GOMS analysis. It allows for early evaluation of design ideas before building prototypes. It also helps to focus design efforts on problematic parts of a system. It suggests improvements in designs for better user experience. Quantitative evaluation with GOMS. It predicts the execution time of tasks performed by skilled users. Operators in a GOMS model are assigned estimated times. The sum of these times predict overall performance time. Applicability in multitasking interfaces. GOMS predicts work with interfaces where users perform multiple tasks simultaneously. For example, in a catalog sales interface, a salesperson may talk on the phone, type, or use a mouse and visually search the screen concurrently. GOMS can predict the time to perform well-learned tasks involving both sequential and parallel operators. Predicting learning time with GOMS. GOMS can be used to predict the time it takes to learn a specific task. Predictions are made by estimating the time needed to learn each step in the process. It assumes that users already know how to perform individual operators but need to learn how to combine them efficiently. Method learning time. GOMS predicts the time required for user to learn methods, that is combining operators into effective sequence and efficient sequences. Users may need time to understand selection rules for distinguishing between times. This method learning time is crucial for users adapting to a new application on their current workstation. Predicting error frequency. GOMS can also predict the frequency of error resulting from forgetting. The interface's demand on user memory during task performance influences the likelihood and location of error. Research indicates that GOMS can provide insights into when and where errors may be more frequent based on memory requirements. The next question was, in what situations does GOMS apply? GOMS analysis is applicable to situations where users have already mastered their task, which are known as cognitive skills. Cognitive skills refer to situations where users are not problem solving but acting on tasks they are familiar with. GOMS is effective in user-paced passive systems where users instruct the system and the system responds accordingly, such as text and graphic editors, spreadsheets, and information browsers. It has been successfully applied to various applications like operating systems, ergonomic design systems, CAD systems, map digitalizers, and even flight management computers in commercial airplanes. GOMS can also be valid in single users active systems where the system introduces unexpected changes as seen in models for radar monitoring and video games. The analysis can describe the behavior of surrogate users in situations where the overall task is defined by the user's needs and an employee acts as a surrogate user to assist customers. GOMS is not limited to routine or repetitive tasks. It extends to creative, non-repetitive tasks as well. This table shows the references of few classic and some recent work that span different uses of different versions of GOMS. The next question was, How do you use GOMS? GOMS can be used in two ways, quantitatively and qualitatively. Let's see its quantitative use. It helps to predict the time it takes to perform tasks or learn something. It is useful when choosing between different systems or design options. One can decide between two office automation tools by creating GOMS model for each and compare predictions. It allows us to balance factors like upfront cost, task speed, and learning time to make an informed decision. The prediction in justifying or rejecting the cost of redesign was shown in the example of digitizing map by Peter Hunold and Werner Kuhn in 1994. Let's see its qualitative use. It evaluates design ideas even before a system is built. It doesn't require a working system. It can be applied in the early stages of design. It is useful for considering redesigns for existing systems. It helps to estimate training cost and performance improvements for a new design idea. It also allows for justifying or rejecting the cost of redesign based on the predicted learning and performance times. The example of qualitative redesign of a system using GOMS model was by Richard Gong, who used it to design an ergonomic CAD system that analyzed job tasks to prevent worker injuries. The CAD system determined optimal height for conveyors and cars on an assembly line, reducing the risk of back injuries for workers lifting car batteries. Here are the views of Jacob Nelson on using a version of keystroke level model. He was a distinguished engineer at Sun Microsystems. He used a GOMS model to analyze the impact of adding buttons to a web interface. He was working on a new website, so decided whether to add buttons to the home page. His goal was to justify why it might not be a wise decision to add new buttons. He used the simplified version of keystroke level model of GOMS to estimate the time it takes for a user to scan, see, and reject a button. This estimated time was then multiplied by the number of users and the value of their time to calculate the estimated cost per year. Nelson chose simplicity because he had limited time and couldn't test on actual users. The precision of testing would be wasted due to the uncertainties in other numbers used for the estimate. He needed a quick ballpark estimate, and GOMS analysis served that purpose for him. He also needed a clear explanation for non-experts. GOMS helped him convey his analysis without technical jargon, adding credibility to his presentation. While Nelson acknowledges the downside of his quick estimate, he emphasizes the importance of flexibility in the interface design. He believes that human flexibility will be crucial in the future of human-computer interaction. Automated tools like GOMS addresses some problems, but the field evolves quickly, requiring a combination of tools, quick testing and support facilities for HCI professionals to adapt effectively. The next question was, who can use GOMS? Different people with varying levels of training can use it depending on the version and specific design questions. Few learning was done through short courses or tutorials, while others learned it from academic lectures or published literature. For example, civil engineers like Hunold and Kwan used GOMS to solve a task-related issue in digitizing maps without being a psychologist. Jacob Nelson found that even undergraduates in their first HCI course could predict task times using GOMS as well as experienced usability experts. However, In more complex situations like analyzing a flight control computer, a deep psychology background might be necessary. The sixth question was, can GOMS be trusted? The answer to this, according to the author, was yes, it can be trusted because researchers have thoroughly tested GOMS models in the past decade. These tests, reported in respected publications, verify GOMS predictions. GOMS is now considered trustworthy for predicting user performance. Designers can confidently use GOMS, knowing it reliably predicts skills, performance, and learning time without constant testing against real world data. The next and the last question was, is GOMS worth the bother? To answer this, the author first looked into the importance and the benefits of GOMS. GOMS provides unique predictive insights into long-term skilled user behavior, offering quantitative predictions that other usability methods may not capture. GOMS plays a crucial role in predicting cost savings or increases, as seen in the example of Hanold and Kanu's map digitizing. In this example, the analysis may have predicted a 73% reduction in performance time for routine tasks, resulting in significant cost savings of about $730,000, and the example of 9x telephone operator workstation could also be considered as one of the best example of GOMS analysis. In this analysis, indicated that choosing a more efficient workstation could potentially save 9x about $2 million annually. These examples highlights how GOMS can be applied to real-world scenarios, providing quantitative predictions and demonstrating its practical value in assessing efficiency and economic impact in specific tasks. GOMS also reveals usability issues not found through normal development, emphasizing task structure and uncovering inconsistency. It serves as a basis for documentation and tutorial design by focusing on task structure and user knowledge, aiding in overall design guidance. Studies such as GOMS highlighted that using GOMS is not overwhelming difficult and takes a relatively small portion of the project time, making it a practical and efficient usability analysis tool. Thus, the effort invested in applying GOMS analysis is considered valuable and worthwhile. Additionally, it mentions the ongoing development of computer-based tools aimed at simplifying the construction of GOMS models, automating tedious tasks, and facilitating easy exploration of hypothetical scenarios like what-if analysis. The use of such tools is expected to enhance the efficiency and user-friendliness of GOMS analysis. In the conclusion, the author discusses about the uses and when not to use GOMS. As we know that GOMS is a modeling technique used by software designers to analyze the complexity of user interactions in an interactive system. In simple terms, we can say that it helps designers understand and model how users behave in the system by breaking down their actions into goals, operators, methods, and selection rules. This analysis aids in designing more user-friendly and efficient software interfaces. It is beneficial when designing for users with specific skills and in situations where task goals are clearly marked and can be modeled, such as designing for experienced users. When not to use GOMS. In cases of systems catering only to novice users, alternative methods like laboratory usability tests or cognitive walkthroughs may be more appropriate. For cutting-edge technologies with operators that are not well understood, like gesture recognition or virtual reality, GOMS might not accurately predict learning time. In conclusion, we can say GOMS is a valuable tool in usability analysis, but its applicability depends on the specific characteristics of the design situation.